Hey guys, we have a lot to get to today. I'm going to get right to the videos. The change from what we did last week is now there'll be a number in front of the first term. So instead of x squared, now you'll have something like 2x squared.
Polynomials in the form ax squared plus bx plus c when a is not equal to 1 and a is not a common factor. Here we have 4x squared minus 4x minus 15. Notice that 4 cannot be factored out of this trinomial, so if this does factor, it's going to factor into two binomial factors. And for the trial and error method, we'll construct our factors based upon the fact that the first terms of the binomial factors must come from the factors of 4x squared, and the second terms of our binomial factors must come from the factors of negative 15. So what we're going to do is use a trial and error process to construct binomial factors, and then we'll check to see which binomial factors have the sum of the inner product and outer product that's equal to the middle term of negative 4x. So for the factors of 4x squared, we could use 2x and 2x, but we could also use 4x and x. Let's go ahead and set that option up here below. Again, because we're using the trial and error process, we're not sure which one is going to work. And now we're going to place the factors of negative 15 into the second positions and check the sum of the inner and outer product to see which will give us the sum of negative 4x. Well, the factors of negative 15, we could use negative 3 times 5, negative 5 times 3, or even negative 1 times 15, or negative 15 times 1. Again, we're not sure which of these factors are going to work until we try it. So for example, if we use the factors negative 3 and positive 5, we could put a minus 3 here and a plus 5 here. Let's go ahead and do the same below. And now we'll check the sum of the inner and outer products. So here we have negative 3 times 2x, that's negative 6x, plus we would have 2x times 5, that's 10x. Well, this gives us a sum of 4x, and we want a sum of negative 4x. So we have the right number, wrong sign, so it's actually going to be an easy fix. We just have to switch the signs of our factors. So we'll change this to plus 3, and we'll change this to minus 5. And now if we check this, we'll have positive 6x plus negative 10x, which does give us negative 4x, our middle term. So this is how you go about using the trial and error method to factor trinomials when a isn't equal to 1. Notice how we didn't have to go down to our second option of using 4x and x. These are the two binomial factors of the given trinomial. Now let's take a look at a second example. Notice how there are no common factors among these three terms. So the first terms of the binomial factors must come from the factors of 20x squared. And the second terms of the binomial factors must come from the factors of positive 3. So the good news is there's not very many factors of positive 3, but there are quite a few factors of 20x squared. We could use 5x and 4x, but we could also use 10x and 2x, and we could also use 20x and x. And then for the factors of positive 3, since the sum of the inner and outer product has to be positive, we'll only use the positive factors of 3. So let's try using plus 3 and plus 1. Notice how the inner product is 12x, and the outer product is 5x. This gives us a sum of 17x, and we want positive 19x, so that's not going to work. Let's go ahead and try it here. Plus 3 plus 1. Well, here we have 6x, plus the outer product is 10x. That's 16x, still not 19x. And this isn't going to work either. If I put plus 3 here and plus 1, notice how we have 3x and 20x, that's 23x. So let's go ahead and switch the placement of our two factors. Let's try plus 1 and plus 3. By the way, we know if we're looking for a sum of 19x, there's no way we're going to have a factor of 20x since all the factors are positive. So we won't even check this one again. Let's check the first one. The inner product is 4x. The outer product is 15x. That's good news. This sum is 19x, which is equal to our middle term. So we found the correct factors of our trinomial using trial and error. We have the quantity 5x plus 1 times the quantity 4x plus 3. Now we're going to take a look at these same two problems using the grouping technique as well as using a method called bottoms up.
So that method was a trial and error method, and that's what I've always used and taught. But in researching this, I found this other way of doing it that the guy pronounces as a shortcut. So I'm going to give that to you right now. I'll give you the shortcut, and if it works out for you, go ahead.
This quadratic. Notice how the a value here is not 1. To solve this quickly, we're going to use a trick. We're going to copy the same quadratic down without the coefficient, x squared plus 7x, and we're going to multiply the first number with the last term here, which is 6 times negative 3. It's equals to negative 18. We're then going to factor as normal. We have x. What two numbers multiply to be negative 18, yet add to be 7? We have positive 9, negative 2. 9 times negative 2 is negative 18. Positive 9 and negative 2 make positive 7. Notice how I'm not using the equal sign here because we're just using this cool kung fu trick. So the next part is to actually divide by the leading coefficient, which is a 6. So we have 6 here and here because we have leading coefficient 6. And then we simplify. So this becomes x plus. Divide top and bottom by 3, we get 3 over 2. X minus 1/3. So the final step is to take the denominator and to move it in front of the x's. So our final answer is actually 2x plus 3 and 3x minus 1. Excellent.
And of course we have our favorite doctor that we're going to show a little video on. It's about 5 minutes. I'm going to put some of that on here. We'll do one with him because I know you miss him. And that'll sum it up.
Only x. This has a 3 and an x. I can't pull anything out. Any grouping possibilities? I can group out an x here, but then I'm still left with that 4 dangling in the wind. So this doesn't look too good. So let's just see if we can try to factor this and say, well, what would it look like to factor this? Well, it would have 2 pieces if it were to be factorable. So let me actually try to write in those 2 pieces here. And these are both going to be binomials. They're going to be 2 pieces to this. 2 pieces to this. And now what are we going to do? I'm going to want those 2 pieces to have the property that when I FOIL it all out, you know, it's going to equal this. So let's just think through how that's going to play out and the possibilities. Well, the first 2 terms here, I want them to be 3x squared. Now there are a lot of ways of breaking this up. I could break it up like, for example, a 3 here and an x squared here. That would work. I could put in a 3x and an x here. I could put in an x and a 3x here, and so forth. I could do a lot of possibilities here. In fact, there's even more exotic ones, but I won't even think about those right now. Let me try some easy one. Actually, putting in a 3 and an x squared here is not a great idea, only because then later on in life when I'm doing the inside stuff and the outside stuff, I'm going to get some x squared somewhere in here. And that actually might not play out too well since this is the only x squared I have. So what I traditionally try to do is to break up the x squared by putting some of the x here and the other part of the x here. So let me put a 3x here and an x here. Now, by the way, I am not giving any kind of warranty or guarantee that this is always going to work. But this is the way most of these things tend to go. So I'm trying to show you a general way of starting to think about it and seeing if it works. If this doesn't work, you'll have to try something else. So don't panic. Okay, anyway, notice this has the pleasant property that when I multiply these 2 things out, I do get that first term. Okay, but now I got to get everything else to work out. Now, how am I going to get everything else to work out? Well, let's see. These two terms have to multiply to hopefully give me the minus 4. Now, if you think about that for a second, the product of two numbers here is going to be negative. That tells me that the signs of these numbers have to be opposite. You see that? Because if they're both positive, then that product would be positive. And if they were both negative, that product would be positive. So in fact, what I have to do is have opposite signs. Okay? And it has to be two numbers whose product is 4. Well, there are a lot of possibilities. There's 4 and 1, there's 2 and 2, there's all sorts of possibilities. So what we have to do now is think about which possibility is going to give us everything else. Let's think of the 2 and 2 possibility for a second. Imagine I write in a 2 here and a 2 here. Can you see them in invisible ink? There they are. What would happen? I would get the 4 over here, but this would give me a 2x, and this would give me a 6x. And the question is there any way to combine a 6x and a 2x and make it into just an x by itself, or a negative x? And if you have a 6x and if you add it to 2x, or if you subtract it from 2x, I'm not going to get it. So that 2 factor doesn't look too good. So it's probably going to be a 1 and a 4 factor. That's the next thing I'm going to try. It may not be, by the way. I want to point out, it may not. This may not be factorable. But if it's going to be factorable in an easy, nice way, then probably we're going to have a 1 and a 4 thing. But I've got to consider all the possible signs. For example, 1 minus 4, minus 1, 4, and then putting the 4 here maybe. 4 minus 1, and then minus 4, 1. Okay, a lot of things to check, and let me show you how I would actually check those things. So let me write the problem back here. This problem is 3x squared minus x minus 4. And let me write down all those cases I have to consider for that bottom thing, because here's where we are right now. We have this. We know it's going to look something like that, and now what I want to do is figure out what's going to go in these holes. Well, what are the possibilities? Well, I could put in a plus 1, but then I have to put a minus 4 here. I could put a minus 1, and then put a 4 here. I could put a 4 here, and a minus 1 here. These are positive. And then I could put in a minus 4, and then a plus 1 here. Those are all the 4 possibilities of putting the 2 different signs in different places. You see, they're all different possibilities. We know the 2 thing can't happen because I can't get that middle term. And now what I'm going to do is just sort of go by trial and error and see which one of these actually might give us the answer. Maybe none of them will, but let's try. So the first one, if I do this, how would that look? Well, let's see. The first terms give me the first term here. The inside term gives me a plus x. The outside term gives me a minus 12x. So that combines to give a minus 11x. So already I can stop the game. I know that's not right. So let's move on. What about here? Well, in this case, the first 2 terms, of course, are good. The inside term, I get a minus x. The outside term, now I get a plus 12x. That gives me a plus 11x. Hold the presses. We're done. Doesn't work. Let's go there. This might not be factorable, folks. Who knows? Here, what I see is the first term is okay. Then I have a 4x, and then I have a minus 3x. So 4x minus 3x is actually plus x. So close. Do you see it? It's still plus, and I need minus. So even though I don't want to, I have to throw it away and hope for the best down here. Let's see what happens here. Here I see 3x squared. Here I see a minus 4x. Here I see a plus 3x. And a minus 4x plus 3x is a minus x. And the last 2 terms give me the minus 4. This is actually a correct factorization. Great! So in fact, this is the way that one can think about trying to factor a trinomial into 2 binomials. There's 2 terms in each of these things. And the idea is to break up that term with the squared in it in a reasonable way, and then try to fiddle with the constant term, thinking about the signs, and seeing how the signs would play out to make this thing work, and then trying the possible cases. Now, this is quite an exorbitant way of doing this. In reality, you might actually be able to try them pretty quickly once you get into the habit of it.
Okay, I hope you enjoyed those videos and they were informative. If you have an issue, please get in touch with me. I'd be glad to see you on a Zoom call and can go through these things with you a little bit further. Good luck with the problems.